Good morning, students. In this session I am going to discuss the first law of thermodynamics. So noted it down. First law of thermodynamics. According to first law, energy neither be created nor be destroyed, but it can be changed into one form to another. One form to another. This is our first law of thermodynamics. Let's we discuss, suppose, initial, internal energy of the system is suppose U1 and heat absorbed is Q. Work done on the system is W. So the final internal energy equal to U2. So U2 equal to U1 plus heat plus work done on the system, and U2 minus U1 equal to Q plus W, and change in internal energy equal to Q plus W. This is our equation for first law of thermodynamics. Change in internal energy, heat given to the system, work done on the system. This is simply we can explain about the first law of thermodynamics. Next we discuss the internal energy. Few points related to the first law of thermodynamics. Types of process also we discuss here. For isothermal process, as we know, isothermal process, the process proceed at constant temperature is called isothermal process. So temperature is constant, so change in internal energy equal to Q plus W means heat, and work done, so work done equal to P del V. We all know about this, reversible and irreversible, 2.303 and RT log V2 by V1 or V final by V initial. In case of isochoric process or isobaric, at first isobaric process, we know that this process which proceed at constant pressure, so pressure is constant, del U Q plus W, simply we know that relation with the isobaric process. Next we discuss isochoric process. In isochoric process, we know that takes place at constant volume. Means change in volume is constant, and change in volume means change in volume is equal to change in internal energy. So del V equal to Q plus W means heat plus work, or Q plus, we know that work P del V. So in this way, or we know the relation del U equal to at constant volume. Heat changes at constant volume is called as internal energy. You can write also heat changes at constant volume is called change in internal energy. Internal energy. So let's we talk about the internal energy. Internal energy. The sum of different types of energy present in a system called internal energy. Energy. It is represented by U. It is a state function. We have discussed in the previous video about the state function. State function, internal energy is all type of energy present in the system, like kinetic energy, potential energy, nuclear energy, vibrational energy, so on, all types of electrical energy, so on. The factor, next, the factor affecting internal energy. Note down the first. Heat given to the system, heat given to the system or leave out from the system. From the system. Work done on the system or by the system. By the system. Matters into the system and leave out from the system. Matter enters into the system and leave out from the system. From the system. So this is the internal energy, students. Or in another way, you can also explain the internal energy. Suppose at first this is our system. Suppose it is the state 1 and it is the state 2. At state 1 the temperature is 1 and internal energy is E1. And state 2, when work done on the system, temperature becomes changes and internal energy also becomes changes. So here we represent the internal energy by E1 or E2. So students, in this way you can also explain the internal energy. Change in internal energy is E2 minus E1. We know that change in energy is directly proportional to change in temperature. Without temperature there is no state changes. In case of solid or liquid, the change in energy is directly proportional to the mass of the substance, because we know that E equal to mc square, and change in energy is directly proportional to ms, change in temperature, and or as at first m and del T, or change in energy equal to, by removing disproportionality sign, we use S del T, and S is the specific heat. So in case of solid or liquid, change in energy directly proportional to the mass, or we can say that change in energy directly proportional to the mass and change in temperature. So by removing this particular constant, by removing this proportional sign, we use constant which is a specific heat. So del E equal to mass, specific heat, and change in energy. In case of gas, in case of gas, we know that change in internal energy is directly proportional to the N, means number of moles. We talk about here internal energy, not the means sign of E is used for internal energy. So del E is directly proportional to N del T, and del E equal to N CV del T. Here another relation came. CV we already discussed, which is called the molar heat capacity at constant volume. Now del E and CV del T, and we know that as constant volume heat equal to N CV del T. It is when heat given to any system at constant volume. So we can say that del E equal to QV. So students, write down the point related to it. Heat given to any system, heat given to any system at constant volume is called change in internal energy. Change in internal energy. Here I am explaining in two ways. So learn it properly. Thermodynamics chapter is very important chapter. So give maximum time and pay more attention on this chapter and on this topic also. So let's discuss the sign convention for heat and work in IPIC. At first, about the heat. Heat loss by the system. Loss by the system. We use negative. And we know that heat release, which is called exothermic process. Heat gain by the system. Gain by the system. Positive sign should be used, and the process takes place is called endothermic process, because in an endothermic reaction heat is absorbed. In case of work done by the system means expansion. Whenever the work done by the system, expansion takes place, and the sign used is negative. And when work done on the system means compression. Work done on the system, compression, and the sign becomes positive. In case of energy of the system increases, so change in internal energy is positive. If energy of the system decreases, means del U is negative. If gas expands, if gas expands, then V2 is greater than V1. Work is done by the system. Therefore, W is negative. If gas contract, then V2 is less than V1. Work done on the system. Therefore, W is positive. So this is the sign convention. Remember it, learn it. Next topic is enthalpy and enthalpy change. Enthalpy and enthalpy, change in enthalpy, not enthalpy and change in enthalpy. At first write down the definition of enthalpy. Enthalpy symbolized by H. It is the heat content of a system, and it is defined as the sum of internal energy and pressure volume work. It is the heat content of system and defined as sum of internal energy, pressure, volume, work. Means H equal to internal energy and pressure, volume, work. Simply. First point, it is a state function. It is a state function. Thermodynamically sign for enthalpy is, if del H positive means heat absorbed and the process is endothermic. When del H is negative means heat release and the process is exothermic. Means we can say that del H. Now, at first we discussed the change in enthalpy. So what is enthalpy, students? It is the heat content of a system and it is defined as a sum of internal energy, pressure, volume, work. So next topic is change in enthalpy. Enthalpy change. The heat change at constant pressure, called change in enthalpy. Remember, constant pressure. So change in enthalpy is called, when heat changes at constant pressure, this is called the change in enthalpy. So we derive the equation. We know that Q plus W means, this is the first law of thermodynamics. According to internal energy is equal to heat and work done of the system. So U equal to Q and put the value of P. W means it comes P del V and U2 minus U1. Change in internal is written like this also. Q minus P take common and V2 minus V1. Now U2 minus U1 equal to Q minus PV2 plus PV1 and U2 plus PV2 minus U1 plus PV1 equal to Q. Q here, this come there, and this is equal to H2 minus H1. We know that this is called heat, and del H equal to QP. So in this way you can also derive this formula, or del H equal to del U, and instead of W we can write P del V. So now relation between del H, del U and P del V. And P del V. According to definition, of enthalpy, enthalpy is the sum of internal energy and pressure volume work. The change in enthalpy del H may be given by del H del U plus del PV, or del H del U plus P del V plus V del P, change in pressure and change in volume. So, but at constant pressure, this comes del H equal to del U plus P del V. So pressure is constant, so the derivation comes del H equal to del U plus P del V. Now the relation between heat at constant pressure, heat and constant volume, or change in enthalpy and change internal energy. The difference between del H and del EU or QP or QV is not important for reaction involving solid and liquid. It is important for reaction involving gas. So write down the statement also. The difference between change in enthalpy, change in internal energy, that is heat at constant pressure and heat constant volume, is not important for reaction involving solid and liquid. Remember it, solid and liquid. It is important for reaction. It is important for reaction involving gases. Suppose in a gaseous reaction, VA and VB. VA and VB is the total volume, of the reactants and product respectively, and products respectively. So Na mole of gas and Nb moles of gas are the number of moles of gaseous reactants and products. The change is studied at constant pressure and constant temperature. Now from the ideal gas equation we know that PV equal to nRT. So PVA NART or PVB equal to NBRT. So PVB minus PVA equal to NBRT minus NART. We can write this also, or PVB minus VA equal to RT NB minus NA, or P, we can write change in volume also, and RT, this is called the change in number of moles. So change in nRT, this type also, this way also change in nRT, but at constant pressure, del H equal to del U plus P del V. Now del H equal to del U plus, we can write del nRT also instead at constant pressure, so we can write del nRT also. So QP equal to QV plus del nRT, these equations come, or del H equal to del U plus del nRT. So these two equations form. Now what is del N? Del N equal to number of moles of gaseous product minus number of moles of gaseous reactant So we can write here del N equal to product minus reactant. Del N is also represented by del Ng. It is also represented by del Ng. So students, today we have completed our enthalpy and change enthalpy. In next video we will discuss the next topic also. That's enough for today. Go through the topic.